Hello YouTubers, Uncle Pythagoras welcomes you back to his channel. Today we are going to do grade 11 inequalities, right? Let's take the very same example, the first one. Example 1, you are given x squared minus x is less than 12. Right, here they want you to solve for x, but in the way of inequalities. Inequalities is when you have less than, greater than, less or equals to, greater or equals to. These are the four signs that give us inequalities. No longer equal sign. But though at the end we resort to equal sign when we're solving the problems. But we consider, bear in mind that the condition that we're given at. Here we're given that x squared minus x is less or equals to 12. Let's make our life easier. You can convert this or change this into x squared minus x minus 12 is less than 0. Now we have taken our 12 on the right hand side to the left hand side, and our sign does not change. The only time when our sign of inequality change is when you multiply by -1. When you multiply by -1, if it was facing to the right, it will face to the left. In other words, if it was less than, it becomes greater than. If it was greater than, it becomes less than when you multiply it by 1. So here we did not multiply. Remember? Right. Let's solve for x. We find that x the factors of 12 that will give us 1 when we add or subtract is going to be 3 and 4. Are not the same. The signs must be different. The bigger one must have a negative. Now this is what we have. Remember when I say we're going to use these equalities, but at the end we're going to use the equal sign. Now is the time for use the equal sign. It's going to be x minus 4, x plus 3 is equals to 0. Now, we don't drop this, but we ignore it, we pretend as if it is equal sign. It is not less than. But at the end, eventually, when we solve the problem, we are going to consider this condition. This is our condition. Let me just highlight it for you, grade 11. That this is our condition. This is our condition. At the end of the day, when we do our things, we consider that as our condition. Though we have applied the equal sign. Right? X minus 4 is equal to 0, or x plus 3 is equals to 0. Then your x is going to be 4, or x is going to be minus 3. That's how we used our equal sign to maneuver to get our values of x. From there, we don't use the equal sign anymore. We go back to our condition. Our condition says that we have the value of x like this one. We have the value of x at minus 3. We have the value of x at 4. This is what we have. Then at the same time, but in the metric you can do this in the metric, you can do it now, but I will show you many various ways of solving it. You are going to substitute the value of x minus 4. Here you have x minus 4 and x plus 3. This is the conditions that we have. Then you take any value, just before minus 3, it's minus 4. You put your minus 4 here, minus 4 and minus 3, you get a minus 7. That means here you have a negative sign. You take the same thing here, you apply 4 here. 4 minus 4 is going to be, it's just before here and there. Remember here, you put your second to show that this is exclusive. You don't include these 4 critical values. Now you take any number between minus 3 and 4, say for instance 0, for convenience sake. When you put a 0 here, you're going to get a 0 minus 4, which is minus. Now we are dealing with signs here. This is what we call sign test. You get it in metric, where you are dealing with the minimum and the maximum, increasing and decreasing, concavity and all the stuff when you are doing in grade 12. But for now, you are not doing all that, you are doing only simply this stuff. Now you come to x minus 4. You put any value just after 4, you are going to say, for instance, 5. 5 minus 4 is positive 1. The sign change. Now we come to this one, a minus 3. Before minus 3, you get a minus 4. A minus 4 plus 3 is going to be a minus. Come here, you said 0. 0 plus 3 is positive. You come here, you take a 5. A 5 plus 3 is 8. Positive. Now, you draw your line. You start multiplying. Negative times negative, positive. Negative times positive, negative. Positive times positive, positive. This is the condition where I said this is going to help us to understand all the things that we have done. Now, they say everything must be less than 0. And if you check your number line, grade 11, if you check your number line, here is your 0, here is your minus 1, here is your minus 2, here is your 1, here is your 2. When that number is less than 0, any number that is on your left hand side is less than 0. It means we are dealing with the negative. Any number greater than 0, we are dealing with positive on the number line system. Now we are going to apply that number line system here. It says that everything here that we have must be less than 0. Where is it? On the negative side. So you come and say x must be between minus 3 and 4. It means that x must be greater than minus 3. And x must be less than 4. See that? Now we're combining these two together. You put your x in the middle. X must be greater than minus 3. And x must be less than 4. You can represent your answer in that way, or you can represent your answer in this way. Now there is one thing other I want to give you. There is this what we call the interval. The interval notation, It wants you to refer. We come back here to our graph, our number line system. You say that in order for us to get a solution here, x must be between 4 and 3. You say that x is an element of, check, you see, it is here. It's an element of -3 and 4. If you use a square bracket, it means that you are using these two. If it was these two, then you're going to use a square bracket. Square bracket means inclusive. Check here. When we came here, I said this is exclusive. You don't include 3, -3, you don't include 4. That is, in the interval notation, it states that you do not include 3, you do not include 4. Thank you very much, grade 11. Now we can go on and do the next problem so that we will understand more what we are doing. Let's grab example 2. Example 2 says x minus 3, x minus 4 is greater or equals to 12. This is the perfect example to illustrate what I was saying. Right. Here they have done us a favor. We have done everything. In other words, we took it from wherever it was. We came and then we landed here. From here, we start to apply or introduce the equal sign. You say x minus 3 is equals to 0 or x minus 4 is equals to 0. Then your x is going to be positive 3 or x is going to be positive 4. Let me check. X minus 3 is 0, x minus 4 is 0, then x is positive. Right. This is what we have. Alright, this is, we did not include this 12. That's where we have gone wrong. Let's start including our 12. Right, let's take our 12 here. It's 12, isn't it? Right. Let me check, it's 12. Yes, it's 12. Now, we take this 12 on that side. Rather, we cannot just take it, multiply it back so that we can get a constant value as 12. We are going to say x squared, you distribute x squared minus 4x minus 3x plus 12 is greater or equals to 12. You see now, this 12 is going to neutralize this one. You take it back, you say x squared minus 4x, rather this is a common factor, a minus 4x and a minus 3x is minus 7x plus 12 minus 12, I took that 12 that side is greater or equals to 0. Now we have x squared minus 7x. This is 0. I will underline it. This is going to give us 0. Then we are left with x squared minus 7x is greater or equals to 0. Take a common factor x, you are left with plus is minus 7 greater or equals to 0. Now we have two factors. We have x into x minus 7 is equal to 0. Now we start dropping this. We're using the equal sign. Coming forward, we have x is equals to 0 or x is equals to 7. I want to take you step by step, grade 11. X into x minus 7 is equals to 0. Now we say x is equals to 0 or x minus 7 is equals to 0 or x is equals to positive 7. Now we go for your number line. You find that here is your number line. Find that there is a 0 and there is a 7. Remember, our condition is this. Here is our condition. Everything that we have must be greater or equals to 0. It means positive, right? We are looking for positive interval here, right? You put your x here. You put your x minus 7 here. Grab any number less than 0. Say for instance minus 1. You get a minus. Take any number between 0 and 7. Say 1 becomes a positive. Take any number which is greater than or beyond 7, which is 8, which is positive. You come to this one. You take any number before 1, you take 1 minus 1. Minus 1 and minus 7 is minus. Minus 1 minus 7 is minus 8. Your minus 8 is negative. Take a number between 0 and, remember, this is inclusive now. We're going to, because of this side, greater or equals to. Now you shade the dot. It's no longer open like this, right? Then you took any number between 7 and 0. Say for instance 1 minus 7 is minus 6. You take any number greater than 7, which is 8. 8 minus 7 is 1. The 1 is positive. Then you draw your line. You multiply negative and negative, you get a positive. Positive and negative, you get a negative. Positive and positive, you get a positive. See now, that means we are going to have 0 and 7. Here is your 7, here is your 0. We have a positive value here, a positive sign here, we have a negative sign, we have a positive sign. Now we are going to refer to this number line system, right? It says everything that you have on the left hand side must be greater or equals to 0 here. Must be greater or equals to 0 there. Here is our condition. We refer everything back to here. Any number that is greater or equals to 0, it must be positive. Remember, I explained that in the number line. I'll go through it again. This is your number line. You have 0, you have minus 1, you have minus 2, you have 1, you have 2. Any number less than 0 is negative. Any number greater than 0 is positive. So we are going for positive. You can see that the positive is here. Now we start by giving the solutions for your answers. X must be less than 0 and x must be greater than 7. You take these two, you put them together, you find that x becomes on the center. You do this, it will work out on its own. X is less than 0. X is less than 0. X is greater than 7. X is greater than 7. Now this is your answer up to so far, but I want to leave you without giving you another extra lesson called interval notation. In the interval notation, you find that x is an element of, it must be greater. You see, all the way from negative infinity to 0. Remember this square bracket I told you about? It comes to play here because of the inequality of greater or equals to, or less or equals to. Once you see this, it is going to be reflected on your interval notation. And this union means and. And we want the positive. 7 to positive infinity. This is what I wanted you to know. I'm glad that we have the example that is going to give us this so that we'll understand the application of the square bracket. Right. Let's do example 3. You are given that 2x plus 3 is greater or equals to x squared. You take this, that side, or you take this, that side, does not matter. If you take this, that side, you are going to get 0 is greater or equals to x squared minus 2x minus 3. Or we're going to get, you take this, that side, you're going to get that 2x plus 3 minus x squared is greater or equals to 0. Whichever method you're going to use, it come up the same. Whichever method you're going to use, it will come up the same. Let's try and do 2 of them simultaneously at the same time. 0 is greater or equals to x squared. You find the factors of this. The factors of 3 that will give you a 2 is 3 and 1, which is x. X is 3 and 1. Signs must be different. The bigger one must have a negative. Negative plus. Or I said, whatever you do on these 2, you are going to get the same thing. You took this on that side, or you take this on that side. And when you take this on that side, it is going to be this one. Now, if it is like this, remember, it is minus x squared plus 2x plus 3 is greater or equals to 0. You see? Your a here, or the coefficient of x squared, is negative. We do not factorize if there is that case. You start multiplying by negative 1. You come back to this instead. You remember when I told you that everything changes when you multiply the inequalities by -1. If it was facing on the right, or rather, if it was greater than, it becomes less than. If it was less than, it becomes greater than. This is what you are going to apply here. So you multiply throughout here, you get x squared. Negative times negative, you multiply your negative here, you put your oh, let me just do it for my grade 11 so that they will understand what I say. It's negative into negative plus 2x plus 3. You can multiply a 0 by negative, but does not change. It remains 0. Now, this is what I said. You multiply everything by negative, then it will start change this sign. Check this. Negative times negative is positive x squared, or minus 2x minus 3 is less or equals to 0. You see? Everything has changed. Now, find the factors of x squared minus 2x minus 3 that will, when you add or subtract, will give you a middle term, a minus 2. So it's going to be x minus 3 and 1. The factors of 3 that when added or subtracted will give you a 2. It's 3 and 2 are not the same. The bigger one should have a negative. Right, we stand like this. Remember, we've got 0 is less or equals to x squared, x plus 1, close bracket and open the other one, x minus 3. This is the same condition. Do you see that? When we have taken that side, you have to multiply by negative to change the whole thing to be like that. So we have reached a conclusion that today is Sunday. Thank you very much, grade 11. Now we can continue and solve. Whatever method we're going to use here, they are the same. One is the same method from the previous one. Right, you say x plus 1, x minus 3 is equal to 0. You start applying your equal sign. Then x plus 1 is equals to 0, or x minus 3. Right, we can take that out because we have solved, we have proven that it does not matter which side do you take, it will remain the same. Is equal to 0. Right? Then your x is equals to minus 1, or your x is equals to positive 3. Then go to your number line system. Your number line system, remember, what is your condition? Let's circle our condition. Our condition will be this. This will be our condition. I think you remember, you understand by now that what we call condition, the condition is this side. Everything must be less than 0. Right? We have your minus 1. We have your 3, which is inclusive. Now we are going to take x minus 1, here x plus 1, we are going to take x minus 3, Right? Let me shift my 1 here for -1. It is going to interfere with this thing. -1 is here. Right? We put the value of x right here. X is -1 and +3. Then you take any number just before. Any number just before. -1 is -2. You put a -2 here. It's -2 plus 1. You get a what? A -1. Have a negative. Take any number between -1 and 3. We've got a 0. Put 0 here. 0 plus 1 is +1. Take any number just after 3. You say 4. 4 plus 1 is 5. You get a what? A positive.